Notes 13, page 6. I actually did one of the problems already for you. I'll probably just let you work through that one yourself. I want to work through the top one. Now, here's the problem we're looking at right here. Perform the indicated operations and simplify. But compare it with this problem, which is very similar looking to the one we just did. Can you see that those two are the same? Here's the numerator, this answer, the way you look at that, this answer divided by that answer, because this fraction bar acts like parentheses. So they're exact same problem, I'm just using a different division symbol. And because I use that division symbol, I actually have to show the parentheses. The reason I want to point this out is because on your test, I might give the problem to you this way, or I might give it to you that way. They're the same problem. Or I might give it to you this way. Now this way is a little trickier, but you're going to see that they're the same problem. Now the most common mistake here is this x to the negative first. People want to flip it down to the denominator, but you can't do that. You can't flip terms down to the denominator. You can only flip factors. So when you take reciprocals, you have to take them within their original term. So this is a term, and when I take the reciprocal, I'm trying to draw a triangle, not making it too messy. I have to take the reciprocal right there in relationship in that term. So it's 1 over x in the numerator like that. And this one is a term, so you can't flip terms down to a denominator. When you take reciprocals, you have to take, this numerator has to become the denominator of that term. So it has to stay in that relative position. So that would be 1 over x squared. And now we see this problem is identical to the first one. So this is probably the hardest form I could give you that problem in, but all three of these are the same problem. So let's try this next one. There are multiple techniques for dealing with what we call a compound fraction. We have fractions within a fraction. And I could teach these techniques, but we kind of don't have time, so the choice I'm making is relying on old skills rather than trying to teach a new one. So old skills, follow the order of operations. Understand the understood parentheses. So when you look at this, it's this answer divided by that answer. So I need to figure out what the answer to the numerator is. I got to add. So what's the LCD of the numerator? These are always fun to talk about. Well, I've got the denominator of x, denominator of x squared. Those are in factored form. And the LCD, the only factor you see is x. Take the x with the largest exponent you see, it's x squared. So this fraction, 1 over x, I need to multiply that by x over x. This fraction in the numerator, I don't need to mess with it. Over x squared minus 1. So what I have is x over x squared minus 1 over x squared. And I know to divide, I'm going to change to multiplying by the reciprocal. So I want to think about that. The reciprocal, and this is another place where people make mistakes, it has to be the reciprocal of the entire denominator as a unit. You cannot take reciprocals of individual terms to say, I'm going to take the reciprocal of this expression. You have to think of it as, oh, this x squared minus 1 is all over 1, and I flip that as a unit. So let's see. I have in the numerator x minus 1 I didn't leave myself enough room, over x squared divided by x squared minus 1 over 1. I have not flipped it yet, but all I've done is I added the numerators, and these are unlike terms, so it stays that way. I changed this division symbol, the fraction bar, to this division symbol, and then I made sure I took the denominator with the over 1 so I can see that when I flip this, that becomes 1 over x squared minus 1. And now I'm basically multiplying, and to multiply fractions, you basically cancel identical factors. So I need to see if I can factor anything. I can't factor the x minus 1, so I leave it that way. This is x squared, that's already in factored form. The one thing I can factor is the x squared minus 1. That's x minus 1, x plus 1. And so I do see that I have some identical factors. And so I'm going to have to go this way. I have 1 left in the numerator over x squared times x plus 1. So that's the reduced form. All right, now this problem here is similar. I did it the same way. I basically said I'm going to take that answer, divide by that answer. So I got a common denominator for the numerator, a common denominator for the denominator, and then I changed to multiplying by the reciprocal. I factored, canceled identical factors. Over here, I'm showing you that this problem here is exactly that problem there. I just used this division symbol instead of this one. And then here, this is the trickier one. Especially here, don't even think about canceling these y to the negative firsts. Those are terms. Can't do that. And you can't flip them because you can't flip terms. Numerator, denominator, only factors. So if you remove the negative exponent, you take the reciprocal, you have to keep it in the numerator in position, relative position of that term. So you do the same thing here, and then you wind up with exactly what we had over there. Now, one thing I do want to point out, and it's very relevant to what I talked about here. If I wanted to multiply by the reciprocal of this, I can't say, oh, I'll flip that term and I'll flip that term. That is not the reciprocal of x squared minus 1. And that's what this statement here says. And there's just this warning. You can't take the reciprocal denominator until it's all one term. And you flip it as a unit, okay? And now this isn't all one term, but I'm seeing it as 1 times x squared minus 1, and I flip it as a unit because basically exponents do not distribute to terms. That's what's going on here. A plus b to the negative first is not a to the negative first plus b to the negative first. You cannot distribute exponents to terms. So the reciprocal of the answer cannot be found by taking the reciprocal of the individual terms. Just doesn't work. All right, we've got some fun problems coming up next.